Good evacuation is really crucial for good performance and for equipment durability. Equipment that John is using here includes a 5 CFM vacuum pump with fresh oil, a 3/8 inch vacuum hose, and a digital micron gauge. Evacuation removes air and moisture from the line sets and indoor coil, and it also provides another way to check for leaks. Some manufacturers specify a triple evacuation process. Here we are doing a single deep evacuation followed by a decay test. If you haven't already released the nitrogen, go ahead and let it out. When the hissing stops, close the isolation valve to prevent air and moisture from getting into the system.
Now I'm going to swap my pressure gauge for a micron gauge.
Set up the vacuum pump on a level surface nearby. Make sure you change the oil in the pump every few jobs. This is a 5 CFM pump, which is more than enough for a residential system.
I'm going to connect my vacuum pump hose to the end port on this core removal tool. Here I'm using a larger diameter hose, a 3/8 inch hose, because that's going to give me a quicker and probably deeper evacuation.
Make sure all the connections are tight and that the micron gauge is working.
We're connected, so I'm going to go ahead and turn on the vacuum pump and open my isolation valve.
Atmospheric pressure is around 760,000 microns of mercury. Our target here is to get below 250 microns, so we're removing more than 99.9% of the air and the moisture from the system. Manufacturers may have slightly different micron targets, but a deep vacuum is really necessary for all systems. Evacuation goes faster in simple systems with short line sets like this one. It takes longer in multi-zone systems and systems that have been open to the air for a while, and it also takes longer in colder weather. If your micron level does not continue to drop to your target pressure, double check all your connections in your hose and your gauges to make sure there aren't any leaks. Before starting the decay test, let the evacuation run for several minutes below the target pressure. It might make sense to work on wiring or closing up some line set covers while the evacuation is running here. After the evacuation has been running down below the target pressure for several minutes, start the decay test. Slowly close the isolation valve and turn off the vacuum pump. For this system, we got the pressure down below 250 microns, and we want it to stay below 500 microns for at least 10 minutes. Record the time and the starting pressure. If your pressures rise above 500 microns and the pressure keeps rising, you have a leak somewhere. Check the test equipment again, and if the leak remains, repeat the nitrogen pressurization test and the bubble test to find the leak. If your pressure rises above 500 microns, but then levels off at a few thousand microns, you probably have moisture in the system. Keep evacuating the system. As more moisture is removed and you repeat the decay test, the pressures will level off at lower and lower plateaus until it stays below 500 microns. If the system passes, record the time and the final pressure. Some micron gauges have built-in logic that calculates the rate of the vacuum decay. These can tell you if the system passes without waiting for the full 10 minutes. Leave the system isolated until you break the vacuum with refrigerant.